The identity property of multiplication is one of the properties of real numbers that we use all the time but never realize it because it says something so simple. And all it says is if you take a value a and multiply it by 1, the result or product is itself. The value of the expression doesn't actually change. Now, since we're dealing with the concept of 1, it is important to note that 1 is also equal to, or can be represented by, a fraction where the numerator and the denominator are the same. So let's say we have a numerator n and a denominator n that represents 1 or 1 whole. So let's see the identity property of multiplication at work. So let's take 3 and multiply it by 1. What do we get? We get 3. Let's take pi, multiply that by 1, and we get pi. And let's take the fraction 1/2, and we multiply it by 1, we get 1/2. Now, why would the identity property of multiplication be useful? Well, it's useful when trying to create equivalent fractions. So let's take this fraction 1/2, 1/2. We can say that 1/2 is equal to 1/2 times 1. Here we're just applying the identity property of multiplication. And using this property of 1, the fact that 1 can be represented as a fraction when the numerator and the denominator are the same, we can multiply 1/2 by 1 represented as, let's say, 5/5. I haven't changed anything about this expression. We're still multiplying 1/2 by 1, so the product should still equal 1/2. However, when we use the multiplication property of fractions, what we get is 5/10. And so the result is an equivalent fraction. 5/10 is equal to 1/2. And we know this because all we've done to 1/2 is we've multiplied it by 1. In this case, we represented 1 as 5/5. Now we know that these two fractions are equivalent because they represent the same value. They represent the same value, 1/2 and 5/10. They represent the exact same value, therefore they are equivalent. So why would you want to change the way you express a value? If 1/2 and 5/10 are the same value, why would you want to write 1/2 as 5/10? Well, let's do a simple addition problem and see if this property helps us. Let's say we took the fractions 1/2 and we added that to the fraction 3/5. And let's call this our original expression. Original expression. And all I'm going to do is I'm going to apply properties to this expression to change its form or to simplify it. So I'm going to take 1/2 and I'm going to multiply 1/2 by 1. I can do that by the identity property of multiplication because I know it's not going to change its value. 1/2 times 1 is still 1/2, so I'm not really changing this expression. And 3/5, I'm also going to multiply by 1. And what did I use to do that? I used the identity property of multiplication. And I'm just going to abbreviate it like that because I don't want to write it all out. It's going to take too much time and too much space. The next step is to represent 1 in a useful way. So I could represent 1 as 2/2, 3/3, 9/9, but in this case I'm going to choose 5/5. And I'm going to take this 3/5 and I'm going to multiply it by 1, except I'm going to represent 1 as 2/2. And the property that I'm using here is the identity property of multiplication. These two statements are essentially the same. We're just multiplying our original fractions by 1. Just in this third step, we're representing 1 as a fraction. Now, why did I choose 5/5 and 2/2? Well, because if you look at the denominators, when we multiply across, you're going to get 2 times 5, which is 10, and over here you're going to get 5 times 2, which is 10, which will give me two fractions with common denominators. So let's do the multiplication. 1 times 5 is 5, 2 times 5 is 10, and then 3 times 2 is 6, and 5 times 2 is 10. And what property did I use to go from step 3 to step 4? The multiplication property of fractions. Now, I really haven't changed anything about this expression. I still have 1/2 plus 3/5. I've just changed the way those values are represented. I'm representing 1/2 as 5/10, and I'm representing 3/5 as 6/10. And because we now have common denominators, we can apply the addition property of fractions. So we're going to add our numerators. That's going to be 11 over the common denominator 10. And we used the addition property of fractions, to get us there. And now we have our answer. Although it would be more appropriate to convert this fraction into a mixed number. So 10 goes into 11 one time with a remainder of 1 out of 10 parts. And there's no real property that states we can do this. We're just converting a fraction, I should say an improper fraction, into a mixed number. And that is one way the identity property of multiplication can be useful.